today's class we will see how to read the data from the file using fscanf and display it onto the screen. Now here this is how I show the hard disk pictorially, and there is a file by name student.dat, and in that suppose I store ID 101, the name Rama, and the average marks 98.89. Now the question is how to get this data from the hard disk and display it onto the screen. Now first of all we are supposed to open this particular file. So for that we use the function fopen. It has to be followed by the name of the file. What is the name of the file here? Student.dat. Whichever file you want to open, that you have to write here. I am supposed to open this file in read mode. So what I do, I will write R within the double quote. This is the read mode. Now close the parenthesis and end with semicolon. Now what will happen is the function fopen returns some value. If the file student.dat does not exist, the function fopen returns null. Otherwise, the function fopen returns a pointer to the beginning of the file. So whatever it is, let us copy that into one variable by name fp. So here we have to declare fp. Now fp points to the beginning of this particular file because the file name student.dat is existing. Now let us see how to declare the variable fp. fp must be declared as a pointer. Pointer to what? A pointer to file. So this capital letter file is defined in stdio.h. So go here and write hash include stdio.h. Okay, now this int 101 is an integer value, Rama is a string, and 98.89 is a floating point number. So to get integer, string, and a floating point number, and we have to copy that into some variables. So for that let us declare three variables. One is id, which is of type int, and another name is an array of what? Characters, and another it is a floating point number. So we write float followed by average number. Now let me use now the moment I declare int id, char name, and so on, memory will be allocated for the variable id, and then 8 bytes will be allocated for the name, and then 4 bytes will be allocated for average marks. Now here if I use scanf, now can you tell me if I say scanf what will happen? I am supposed to enter the data from the keyboard, and whatever data I enter, integer value will be copied here, name will be copied into name field, and if I enter 98 point, that will be copied into average marks. But remember, we are not supposed to read any data from the keyboard, so I am not supposed to use scanf. I am supposed to get the data from the file. Okay, so if you want to read the data from the disk, so we have to use not scanf, we are supposed to use fscanf. So I will have the prefix f here. So this becomes fscanf. Now if you recall the syntax of fscanf, for fscanf the first argument must be the file pointer. This is the file pointer. This file pointer points to this, so we have to write fp here. So fp comma. Now if I execute this statement, 101 will be copied into id and so on. Now see, 101 will be copied here, and next Rama will be copied here because Rama is a string, it must end with null character, and 98.89 will be copied into this particular field. So we know how to read the data from the disk. Now our intention is to display it onto the screen. For displaying on the screen, we are supposed to use a printf statement. So here if I use a printf, I am supposed whatever I write here, that will be displayed on the screen. Now I want to display the first one, integer. Integer format specifier is %d, and which value stored in the variable id, so I write id here. Now what will happen? This 101 will be copied into this memory location. Next, what I am supposed to print? Rama. Rama is a string, so here we have to write %s format specifier. And Rama is available in which variable? Name, so I write a name here. What will happen? This Rama will come and it will be displayed on the screen. Next, I am supposed to display 98.89, which is average marks, which is of type what? Float. So what format specifier I should write? %f. Now here I should write average marks. If I close a parenthesis and end with semicolon, the 98.89 is read from the memory and that will be displayed onto the screen. So this is how we can read the contents of the file and then we can display it onto the screen. Now all these statements must be enclosed within braces, and here I write void main. So this is how we can write the complete program. Now let us see how to read data from the keyboard and write into a file. Now normally we enter the data from the keyboard and whatever we enter that will be displayed on the screen. Suppose I enter 101 and then Rama and 98.89. So these three values have entered from the keyboard and that I want to write into a file. So how to, first of all, tell me how you can enter this data from the keyboard. I can write scanf, %d, %s, %f. All these format specifiers must be enclosed within double quote, and then you have to write &id, name and average marks. Now if I execute this, we can enter these data from the keyboard. Now here let us display id should be of type integer. What is the name? Name must be an array of characters. Then you have average marks. Average marks must be of type what? Float. Now what will happen? The moment you declare something like this, memory will be allocated for id, memory will be allocated for name. How many bytes? 8 bytes will be allocated for the name, and then for average marks 4 bytes will be allocated. Okay, now here 101 will be copied into id, and then if I enter Rama, Rama will be copied into this particular field and it ends with what? Null character, because Rama is a string. And then what will happen? 98.89 will be copied into average marks. So this is how the data is read from the keyboard and that is stored in the various variables, in this example id, name and average marks. Now the question is how to write this data into a file. So for that what we do, this is the pictorial representation of the hard disk. Now here what I do, I have to open a file. So let me open one file by name student.dat. So here student.dat, I have to write in which mode? I have to open this file in which mode? Write mode. So I write W within the double quote. I have to write this data into this. So we have to open the file student.dat in which mode? Write mode. Now here, next, now let us see what will happen. A file by name student.dat will be created, and remember the function fopen may return some value, and whatever you return that should be copied into which variable now? fp. Now here student.dat, the file is created, so it will point to the beginning of the file. Okay, now let us declare the variable fp here. So fp, I can declare it as a pointer to what? File. Okay, now the declaration of file is available in stdio.h. Now the data has been entered from the keyboard and that is available in the variable. Now we have opened a file. Now the question is we have to print. If I say print %d, what is id? id is of type, id is an integer, so I am using format specifier %d here, and I am going to display 101. Now if I write a %s format specifier and then if I write a name, what is displayed? Rama is displayed. Next, if I write %f average marks, what is displayed? 98.89 is displayed. Now remember here we are using printf statement. Now if I use printf statement, I get this 101, Rama and 98.89 on the screen. But remember, I am not supposed to display the data onto the screen. Instead, I am supposed to write the data available in these variables into the file using the format specifiers. So I cannot use a printf statement. Now I am supposed to use what? fprintf. Again, the syntax of fprintf is first you should write the file pointer. So here I write fp, fp points to where? Fp points to this. Now the value of id, name and average marks will be written into this particular file. So 101 is read from the memory and it is written into this file. Next, Rama will be read from the memory and it is written into this file. And next, marks also will be read from the average marks will be read from the memory, and that will be written into the file. So this is how the data read from the keyboard can be stored in a file. Now our job is over. All these statements must be enclosed within braces, and here we write void main. The declaration of the scanf and fprintf, all those things will be available in stdio.h, so we can include stdio.h here. Okay, next, now let us see what is the syntax of fprintf. Already we have used fprintf. Now let us see the syntax. Now here, if you observe here what we have, this is the syntax of not fprintf, it is the syntax of fscanf. So if I want the syntax of fprintf, this scanf must be changed to printf. So here I write printf. So what is fp now? fp is pointed to a file from where the data has to be read. This is wrong. So here what you have to write? fp is a pointer to a file to where the data has to be written. Next, here if fp is pointing to standard input, earlier fp was pointing to standard input because here we have what? Scanf. Now we are written printf, so fp must be pointing to standard output file. So here I write, if fp is pointing to standard output, then data will be displayed onto the screen. If fp is pointing to standard output, then the data is displayed on the screen, but if fp is pointing to a file, then the data is written into the file. And this remains the same, that is format string contains the format specifiers such as %d, %f and so on. So the format specifiers specify the order and type of data to be written into the file. Similarly here, variable list contains a list of variables separated by comma. Here you have to write all the variables separated by comma. The number of format specifiers must be equal to number of variables. Here how many format specifiers will be used, those many variables must be present here. The order and type specified in the format specifiers must match with the order and type specified in the variable list. Similarly, here it is not UIF negative value when a problem is encountered while writing the data into the file. So whenever there is a problem, when we write into the file, the function fprintf returns a negative value. Otherwise, number of characters written into the file if data is written successfully into the file. So this is the syntax of fprintf, and we have seen how fprintf works. Okay, now let us see what is fprintf. Can you tell me what is fprintf? Fprintf is a function which is similar to printf function, but only thing is we are prefixing with f. And now if you observe, another change is the function fprintf, the functionality wise, the syntax wise, except the first argument, rest of the syntax remains same. So only change in the function fprintf, it has a file pointer as the first argument. Printf will not have the first argument as the printf will not have the file pointer as the first argument, whereas fprintf will have the first argument as the file pointer. So rest of the syntax and the working is same as fprintf. Now what is fprintf? Fprintf is a function in C which is used to write the data into secondary device such as hard disk, or you can write into this is wrong, we can write the data into hard disk. It returns a negative value when there is a problem in writing the data into a file. So using fprintf we can write the data into hard disk, you cannot write into CD or DVD. Otherwise, it returns number of characters written into the file. So after writing, if it returns a negative value, it means there is a problem in writing the data into the file. If there is no problem, it returns the number of characters written into the file. So the function fprintf syntax wise is similar to the printf, but only thing is fprintf has the file pointer as the first argument. Rest of the syntax and working is same as printf. So when we have to display the data onto the screen, normally we use printf. If you want to display the data using fprintf, then normally we use printf, and when we have to write the data into a file, we use fprintf. Now let us see how to read the data from the keyboard and write into the file. Now here let me write the input that this is the file I want to create, and I want to create that file in which mode? Write mode. So for that, what is the function I should use? Fopen. Now the moment I execute this statement, what will happen? A file by name input.dat will be created. Suppose input.dat already is existing with some contents. Now the moment we execute this now what will happen? The function, if it is there, the whole contents will be removed. If the file is already there, the contents will be removed. Now here, suppose the file is opened in write mode, but it is a read-only file. Input.dat, assume it is a read-only file, but you have opened this input.dat in which mode? Write mode. Is it possible for you to open this file in write mode? Because it is read-only file, you cannot open this in write mode. In that case, the function fopen returns null. So what fp now contains? Null. If fp equal to null, it means there is error in opening the file, so we terminate the program by writing exit 0. Whenever this condition is true, if more than one statements have to be executed, then all those statements must be enclosed within braces like this. Now, suppose file is not existing. In that case, when I execute this statement, a new file will be created. A new file, empty file will be created, and file pointer points to the beginning of the file. So a pointer to the beginning of the file is returned, and that will be copied where now? Fp. Now tell me, is fp equal to null? Fp is not null. Fp is pointing to this, so fp is not null. So these statements will not be executed. Instead, control simply comes out of this statement. So let us display this message, printf enter numbers ending with Ctrl Z. Now what will happen? The moment I execute this statement, we get the message enter numbers ending with Ctrl Z on the screen. Now let us try to enter the data from the keyboard. Now whatever data we enter from the keyboard, that will be normally stored in buffer. This buffer we call it as keyboard buffer. So here I may enter 10. Whatever I enter here, whatever I enter from the keyboard, that will be copied into the keyboard buffer. At the same time, it will be displayed on the screen. Now, for that, what is the statement I should write here? Scanf. If I write scanf %d ampersand num, what will happen? This num will be the value 10 is read from the keyboard buffer, and that will be copied into num. Now we have to declare the variable num here. So go here and declare the variable num, which is of type what? Integer. So here, the moment I say int num, memory will be allocated, and the name given for this memory location is num. Now what will happen? If I execute this statement, the data 10 will be read from the keyboard buffer, and that will be copied into the variable. So now the function scanf, whenever you type 10 from the keyboard, the function scanf returns 1, indicating one value has been read successfully from the keyboard buffer. And because the function scanf returns 1, we check whether 1 is not equal to end of file. The value of UOF, actually it is -1, it is defined in stdio.h. So the scanf returns 1, UOF is equal to -1, so 1 is not equal to -1. So what we do? We write number into the file pointer. So that can be done using the function fprintf. Now if I execute this, the data available in the variable num will be copied into the file pointing to by fp. So this is the file pointing to by fp, and this is num. So num is there, and what is that? %d means it is a integer value. So integer value is read from the memory, and that should be sent to where? File pointer, that is pointing to this. So 10 is read from the memory, and that is written into the file. along with what? Slash n, because here we have written slash n. Now after writing the data 10 and slash n, automatically the file pointer will move to the end. You need not increment file pointer by 1. Automatically, as and when we write or as and when we read, the file pointer will be incremented. So let us repeat this. So for that I write while loop. Now see what's happening here. As long as the data is not equal to end of file, we keep reading the data from the keyboard and we write into the file. Now suppose I enter 20, that will be displayed on the screen. I will enter 30, that is displayed on the screen. I enter 40, 40 will be displayed on the screen, and 50, 50 also will be displayed onto the screen. Now if I press Ctrl Z, what will happen? The data is read from the keyboard buffer. Already 10 we have read and it is displayed. Now what is the next value we are going to read from the keyboard buffer? 20. The 20 is read and that will be copied into num. So how many values you have read now? One value. That one is not equal to UOF. So it is true. Enters here and send num to the file pointer. So this 20 will come here to the file pointer along with what? This is slash n. Slash n will be appended at the end. File pointer automatically moves to the next position. Again control goes back here. Again we are executing scanf statement. So what will happen? This 30 is read from the memory and it is copied into the variable num. How many values you have just now read? Only one value, and that one is not equal to EOF. So it is true. Control enters into the function and this statement is executed. So you are sending num to where? File pointer. So 30 comes to the file pointer along with what? This slash n will be appended and file pointer will move automatically to the end. On similar lines, 40 will be read, 40 will be written into the file along with what? Slash n. Cursor, the file pointer will be moved automatically to the end. Now 50 is read from the keyboard buffer and that is stored in the num, and using fprintf we send that num to the file along with the new line character. Now file pointer automatically moves to the end. Now let us close the file. That's all. Now let us declare the file. fp is what? Pointer to a file. All this statement must be enclosed within braces, and here we write void main. So this is how we can read more number of values from the keyboard and we can write into the file. Now we know how to write a program to read data from the keyboard and write into the file. But one thing you remember, the function scanf here returns 1, indicating one value is successfully read from the keyboard. Now finally, once you press Ctrl Z, see what's happening. If you press Ctrl Z, have you read the data into the variable num? No. In that particular case, the function scanf returns -1. What is the value of EOF? -1. What the function scanf returns? -1. So -1 not equal to -1, it is equal. What will happen? Control comes out and the file will be closed. So this file will be closed. Now the declaration of printf will be available in stdio.h. So go here and write stdio.h. Why we have to include stdlib.h? Because here we are using exit 0. Now how we know that I should include stdlib.h whenever exit function is there? So if you are using Turbo C, you can move the cursor on any one of the character here and press Ctrl F1. Then you will get one window. If you read that window, in that window it clearly says include stdlib.h or include process.h. So you can either include stdlib.h or process.h. Okay, now let us see how to read data from a file and display it onto the screen. Now let me read the data from the input file. Because I have to read, I have to open the file in which mode? Read mode. So how to open this file in read mode? We have to use the function fopen. Now the function fopen returns a value and that value will be copied into which variable? Fp. If fp equal to null, What does it mean? The file has not been opened successfully. In that case, we display the message error in opening the file and we terminate the program by writing exit 0. So if this condition is true, if you want to execute more than one statement, then all those statements must be enclosed within braces. If there is only one statement is present here, there is no need of braces. In that case, braces will be optional. Suppose fp not equal to null, meaning the file has been created successfully. File has been opened successfully in read mode. Now, suppose a file is there by name input.dat, and suppose already you have 10/n, 20/n indicates new line character. So we have 10, 20, 30, 40, 50. Now, once you now here if you observe 10/n, 20/n, even though I write 10 enter, 20 enter, 30 enter, 40 enter, in the file it will be stored as a /n here. In place of enter key, what is stored here? /n. And this symbol here which indicates end of a file. This is a symbol what I am designating to indicate that it is end of file. Now, the file is opened successfully in which mode? Read mode. In that case, the function fopen returns a pointer to file pointer. So here fp is pointer to this particular file. Now tell me, is fp equal to null? Fp is not equal to null because fp is now pointing to this beginning of the file. So control comes out and let us display the message, the contents of the file are. So here we get the message, the contents of the file are, because here you have the printf statement. Now, this num has to be read from the file and it has to be copied into a memory. So the name given to that memory is what now? Num. So num is of type integer. So the moment I say int num, 2 bytes of memory will be allocated for the variable num. Now, let us see how to read the data from the file. How to read? We have to use fscanf. Fscanf, what is the syntax? Here we have to write the file pointer. File pointer is pointing to this. Then we write %d, then ampersand num. Meaning from the file pointer, try to read an integer value. So what is integer value? 10, and the 10 should be copied into which variable? Num. So 10 is copied into the variable num. After reading 10 from the file, automatically file pointer moves to the next number here. Now tell me what the function fscanf returns. Fscanf returns 1, indicating one value has been read from the keyboard. Is it equal to end of file? No, end of file is -1. 1 is a positive value, end of file is -1. 1 is not equal to -1. So it is true. So what will happen? Let us write num onto the screen. So for that, what function we have to use? Printf. So what will happen is, if I say print num, num is read from the memory and that is displayed onto the screen. So the whole process has to be repeated. So I write while fscanf fp and ampersand not equal to end of file, print it. Let me enclose this printf within the braces. Now tell me, if I execute this, again you have to read from where? File pointer, that is 20 is read into num. So this 20 is read into num. Immediately after that, automatically file pointer points to the next number. Now, how many values are read into num now? Only one value. Is 1 not equal to end of file? No, it is true. 1 is definitely not equal to end of file. It is true. So control comes here. You display num onto the screen. So 20 is displayed. And then again control goes back here because it is a while loop. This set of statements have to be repeatedly executed as long as the condition is true. Once this condition becomes false, then only control should come out of the while loop. So here now 30 is read from the memory and one value you have read, 1 is not equal to end of file. It is true. Control comes here, display 30 and next display 40. Now finally you read 50 into the memory and you send that 50 to the output device. Now if you see, we have displayed 10, 20, 30, 40, 50 on the screen. 10, 20, 30, 40, 50 on the screen. Now finally the file pointer points to end of file. If we try to read now what the function what the function fscanf returns? -1. So end of file is there, end of file will get, what is the value of end of file? -1. This is also -1. -1 not equal to -1, it is equal. So control comes out of the while loop. And let us close the file using the file pointer. So fp has to be declared as a pointer to a file. And tell me, all these statements must be enclosed within braces like this. Here we write void main. The declaration of printf will be available in stdio.h. Exit 0 is available in stdlib.h. So include stdlib.h and include stdio.h. I hope you understood how to read data from a file and display it onto the screen. Now, this is very important. Now, let us read from two files and we write into a single file. Two files have to be opened in which mode? Read mode. And one file has to be opened in write mode. So two files are given. Say one file is std.txt and that file, assume it already contains Ram, Lal, Pal, Khan, Sam and so on. And another file usn.txt. So 101, 102, 103, 104, 105. And both the files are stored in the hard disk. Create a new file by name output.txt and copy the contents of two files std.txt and usn.txt into the output.txt. So here what we have to do, according to the problem statement, we have to create one file by name output.txt in which mode? Write mode. And then we have to read student std.txt and usn.txt. So read from this file and write into the output.txt. Now here Ram is read, 101 is also read and that should be written into output.txt. Lal 102, Pal 103 has been written into this file. So these two files are read and it will be written into one single file in the name output.txt. Finally, we have to display the contents of the file output.txt onto the screen. So if this is the screen, the whole data has to be read from which file? Output.txt, and that should be displayed one after the other. So we will get Pal 103, Khan 104 and Sam 105. So this is the problem given. Now let us see how to write a program to read the two files and write into a file. Now one file is already there. What is the name of that file? std.txt. Let us open that file. It has to be opened in which mode? Read mode. So I write R. So what is the function I should use? fopen. And the function fopen returns a pointer. Let me copy that into fp1. Now if you observe, fp1 now points to the beginning of the file std.txt. So this is how I am going to represent pictorially. Next, we have to open this file. What is the name of this file? usn.txt. This also has to be opened in which mode? Read mode. And we are using, to open the file, we have to use fopen. And the function fopen returns a pointer. And that pointer should be copied where now? fp2. fp2 points to the beginning of usn.txt. fp1 points to the beginning of std.txt. Now fp2 points to the beginning of this file, fp1 points to the beginning of this file. Now we are supposed to write into a file. So output.txt we have to create. So whenever we have to create a file here, we have to open the file in which mode? Write mode. So I write w. So fopen. So fopen can be used to open a file in read mode or in write mode or in append mode also. So the function fopen returns a file is created. If a file can be created successfully, the function fopen returns a pointer to that. So pointer to this fp3. fp3 is pointing to the beginning of this file. So how many variables are there? 3 variables are there, fp1, fp2, fp3. Now let us declare FP1, FP2 and FP3. FP1 is a pointer, FP2 is a pointer, FP3 also a pointer. All of them are pointers to what? A file. And the declaration of file is available in stdio.h. Now, from the first file, let me read the name. So, if you want to read from the disk and copy into memory, we require one variable name of file, which is of type what? Character. I want to read a number from the file and we have to store it in one variable. So, let me declare USN. USN is of type what? Integer. So, if I say name of 5 bytes will be allocated for the variable name. When I say int USN, 2 bytes will be allocated for USN. Now, I write set up an infinite loop. When I write for semicolon semicolon, it indicates that I am going to set up an infinite loop. So, fscanf fp1 percentages name. Tell me what is the meaning of this. Read from the file pointing to by fp1. What is that we get? RAM. RAM should be copied into which field? Name field. So, RAM is read from the file and it is copied into name field. Then automatically the file pointer points to the next one. Next, what we do? We check whether it is equal to end of file. Have you encountered end of file? No. So, if it is equal to end of file, we break. If it is not equal to end of file, this break will not be executed. On similar lines, I read from usn.txt. So, usn.txt, we have pointer fp2 which points to the beginning of usn.txt. So, whenever we want to read the data from usn.txt, we have to use file pointer 2 because file pointer 2 points to the beginning of usn.txt. So, what should I write here? fp2, then I write %d, comma, ampersand usn. Why %d? 101 is of type integer. So, usn is also of type integer. Now, if the value returned by the function fscanf, now what will happen? If I execute this statement, 101 is read from the file and that is copied into usn, automatically the pointer points to the next integer here. Now here, suppose the function fscanf returns end of file. If it is equal to end of file, we break. Now in this example, are you pointing fp2 to end of file? No. So break will not be executed. Control comes to the next statement. Here we are supposed to write a name and usn into this particular file. So using name is what? String. So we have to use percentages. usn is a integer. So we write %d and write slash and append slash and at the end. It means it is the next, we are going to the next line. So we have to write name, usn and attach new line character into where fp3. That can be done using fprintf function. Now what will happen? The moment I execute this, RAM and 101 is read from name and usn. From name and usn, whatever we read, that will be sent to fp3. So fp3 is here. So once you write RAM and 101 into the file, automatically find pointer points to the end now. Now again, control goes back here. Now tell me, if I execute this, fp1 points where? Lal. So lal is read from the memory. Next, if this statement, now automatically pointer comes to the next name. Now, if I execute this fscanf now, we are trying to read the data from where now? fp2. From fp2. From fp2 means we get what? 102. 102 should be copied into where now? usn. Now 102 has been copied into usn. Now automatically this file pointer points to the next integer. Again, now what will happen? We have to write, we are using, when I execute this, fprintf means you are writing into fp3. What has been written? Name and usn must be written into fp3. Name and usn means lal and 102 will come here and they will be written into the output file. And automatically a pointer points to the end of the file. Again control goes back, execute this. If we execute this, name is read from, name is fscanf. When I say fscanf, from where we are going to read the name? fp1. What is fp1? Pal. Paul is read from our file and it is copied into name field. And automatically pointer from earlier pointer is pointing to this, now pointer points to the next name. What is the next statement to be executed? fscanf here. We have to read from where? fp2. fp2 points to where now? 103. And 103 is copied into where now? usn. So 103 is copied into usn. After that, automatically this pointer points to the next one. Now, when we execute this fprintf statement, we write into fp3 from where? Name and usn. Name and usn have to be read and written into fp3. Now, pointer points to the end of the file. Again, we go back. When we execute this, we read from fp1. What is fp1? Con. Con is read from the memory and that is copied into where now? Name. So, con is read from the memory and it is copied into name. Next, pointer automatically points to the next name. Now, when this statement is executed, we read from fp2, we read from fp2. What is read? 104 should be read into where? usn. So, 104 is read into usn. Pointer will point to the next number. Now, see what's happening. When we execute this, name and usn are read and written into fp3. So, con and 104 are written into fp3. Pointer points to the end of file. Now, see the last time we are entering into the loop. Now, if I execute this, what will happen? We are going to read from fp1. fp1 points to where now? Sam. That Sam is read and it is copied into name. Now, after reading, automatically pointer points to the next name. What is the next name here? There is no next name. Now, fp1 points to end of file. But what is the next statement to be executed? fscanf. We read the data from fp2. We read the data from fp2. What is read? 105 is read and that should be copied into where now? usn. So, 105 is copied and that is read into usn, and this pointer fp2 automatically points to the end of the file now. Now, what is the last statement to be executed? fprintf. We are sending name and usn into fp3. We are sending name and usn into fp3 and this fp3 now points to the end of file. Now, again control goes back. Now, if I execute fscanf, now tell me what will happen. fp1 points to where? End of file. So, the function fscanf returns EOF. Is EOF equal to EOF? Yes, we execute break. The moment we execute break, control comes out of the while loop. Now, if you observe, we have read the two files and we have written those two contents into a single file by name output.txt. Now, let us close fp1, let us close fp2 and let us close fp3. Now, our job is over. All the statements. Now let us see. Let us try to open this file in read mode and display it onto the screen. So, what should I do? Open the file in which mode? Read mode. For that, what function I have to use? fopen. And the function fopen returns a pointer to a file, so fp3. Now, fp3 points to the beginning of RAM. Now, fp3 is pointing to the beginning of the file output.txt. Now, we have to print student name and usn. If I execute this statement, what will happen? We get student name and usn on the screen. So, if I say fscanf fp3, one string and integer, one string and integer. So, percentages and percentage %d format specifiers I use. Name comma usn. Here ampersand we use. Now, tell me what will happen? One name RAM and 101 is copied into name and usn, and then automatically pointer points to the next name. If it is not equal to end of file, definitely it is not equal to end of file. So, let us print name and usn on the screen. For displaying onto the screen, which function we use? Printf. So, what will happen? This RAM and 101 is read and that will be displayed onto the screen. So, this has to be repeatedly executed. So, I write while loop. Now what will happen? Again read from FP3. LAL and 102 is read from the memory. It is copied into name and USN. Automatically pointer points to the next one. Now you print. So LAL and 102 is written onto the screen. So like this, each and every data is read from the memory and that will be displayed onto the screen. So now PAL is sent to the screen. Next what will happen? Next CON will be read from the memory. CON followed by 104. Pointer points to the next one. And let us enter into the loop. This will be displayed onto the screen. Now see, where is the pointer now? SAM. Go back. We are reading from where FP3. SAM and 105 is read. And that should be copied into name and USN. Name and USN. It is copied. Now file pointer points to the end of file. But what the fscanf returns now? SAM and 105. So 2 it returns because 2 values are read successfully. Is 2 not equal to end of file? Yes, it is not equal to end of file. Come here, send name and USN to the display unit using printf statement. So what will happen here? SAM and 105 will be sent to the output device. When control comes back here, now FP3 points to the end of file. If you read, the function fscanf returns end of file. Is end of file not equal to end of file? It is equal to end of file. What will happen? Control comes out of the while loop and program will be terminated. So finally we close the file pointer. All these statements must be enclosed within the braces. So here I write void main. So we know how to read from the two files. And we have written into the single file and then we have closed all the files. Again here what we do, we are opening the newly created file in which mode? Read mode, and read the contents of that particular file and send it to the output file. So I hope you understood, and we stop at this point, and some other programs we'll see in the next class.